Hi guys, welcome back. This is Shivi, pursuing my education at Sri Venkateshwara College of Engineering and wearing the ESN 1V21 CS 184. I am here with a familiar topic learned in maths, probability. First of all, what is probability? Probability is a measure of likelihood of an event to occur. Many events can't be predicted with a total certainty. We can predict only a chance of an event to occur, that is, how likely we are going to happen. For example, when we toss a coin, either we get head or a tail. But when two possible outcomes are possible, that is head and tail, but we get the possible outcomes as four, that is head come a tail come a head, and tail come a tail. In this video, we will be going through the topics random variables, probability distribution, binomial distribution, and the Poisson's distribution. Firstly, we learn about random variables. A random variable is a real valued function defined on a sample space that assigns each variable the total number of outcomes. Example, tossing a coin 10 times, the random variable x will be number of heads. Toss a coin till a head, the random variable x is equals to number of tosses that is needed. Toss a die. When we toss a die, the random variable x will be point showing on the face. When we plant 100 seeds of mango, the random variable x will be the percentage of germinating. Test of a test tube or a tube light. X is the random variable x will be lifetime of a tube light or a test tube. Testers of 20 tubes. Then the random variables x will be average of a lifetime of tubes. Types of random variables. There are two types of random variables, discrete random variable and continuous random variable. The example of discrete random variable is counts finite possible values. The example of continuous random variables is lifetimes and the time. Probability distribution. For a discrete random variable, the probability of each outcome x to occur is denoted by f of x. This satisfies the following properties. 0 less than equals to f of x and f of x is less than equals to 1. Summation of f of x is equals to 1. To understand better, here is an example. Roll a die. When we roll a die, we get the possible outcome. We get the 6 possible outcomes. Consider x is equals to the number appear on a face. If x is equals to 1, then the f of x, that is, the outcome will be 1 by 6. If x is equals to 2, then the outcome f of x will be 1 by 6. If x is equals to 3, then the f of x will be 1 by 6. That is the outcome. It goes on till the 6 times. Here is another example. Toss a coin twice. X is equals to number of heads. When x is equals to 0, then the possible outcome p of x is equals to probability of tail and tail. That is equals to probability of tail into probability of tail. That is equals to 1 by into 1 by 2. We get the outcome 1 by 4. When x is equals to 1, the probability of x is equals to probability of tail head or head tail, that is equals to probability of head tail plus probability of tail head, that is equals to 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2, that is equals to 1 by 2. When x is equals to 2, the probability of head and head, that is equals to probability of head into probability of head, that is equals to 1 by 2 into 1 by 2, that is equals to 1 by 4. The advantage of probability distribution is, by the probability distribution, we mean a correspondence that assigns probabilities to the values of a random variable. Example of probability distribution. Check whether the correspondence given by f of x is equals to x plus 3 by 15 for x is equals to 1, 2 and 3 can serve as a probability distribution of some random variable. This is a question. The hint given is the value of a probability distribution must be number on an interval from 0 to 1. The sum of all the values of a probability distribution must be equal to 1. By substituting x is equals to 1, 2 and 3 into f of x, f of 1 is equals to 1 by 3 by 15, that is equals to 4 by 15. F of 2 is equals to 5 by 15 and f of 3 is equals to 6 by 15. We have did same as of f of 1. They all are between 0 and 1. The sum is 4 by 15 plus 5 by 15 plus 6 by 15 is equals to 1. So it can serve as a probability distribution of some random variables of x. We'll move on to the next topic, binomial distribution. In many applied problems, we are interested in probability that an event will occur x times out of n. Let's take an example of binomial distribution. Roll a die 3 times. X is equals to number of 6, S is equals to a 6, N is equals to not a 6. When X is equals to 0, not a 6, we get 3 not a 6, that is 5 by 6, 5 by 6 and 5 by 6. When X is equals to 1, we get 3 outcomes, not a 6, not a 6 and a 6, that is 5 by 6, 5 by 6 and 1 by 6. When X is equals to 2, we get not a 6 and a 6, that is 5 by 6, 1 by 6 and 1 by 6. When X is equals to 3, we get 6, 6 and 6, that is 1 by 6, 1 by 6 and 1 by 6. Let's take another example. If X is equals to 0, f of X is equals to 5 by 6 to the power 3. X is equals to 1, f of X is equals to 3 into 1 by 6 into 5 into 6 to the power 2. If X is equals to 2, f of X is given 3 into 1 by 6 square, that is 1 by 6 into the power of 2, 5 by 6. If X is equals to 3, f of X is equals to 1 by 6 to the power 3. So f of X will be, f of X is equals to 3 by X into 1 by 6 to the power X into 5 by 6 to the power of 3 minus X. Let's take another example. Pumpkin seeds germinate with probability 0.93. Plant n is equals to 50 seeds. Solution: X is equals to number of seeds germinating. F of X is equals to 50 by X into 0.93 to the power X into 0.07 to the power of 50 minus X. P of X is equals to 48, that is equals to 50 by 48 into 0.93 to the power 48 into 0.07 to the power 2. To find the binomial probability, we can use by direct substitution, use approximation, computer software and binomial table. Direct substitution can be had if n is large. Using approximation, we can also find the binomial probability. Computer software, it is the most common source. Most of them use the binomial probability by the computer software. Binomial table, that is the table V. We'll move on to the next topic, Poisson's distribution, and the last topic. Event happen independently in time or space with average. Radioactive events per unit time or space. Radioactive decay. Lambda is equals to 2 particles per minute. Lightning strikes. Lambda is equals to 0.01 strikes per occur. The perfectly random occurrences, it can be shown that mathematically f of x is equals to lambda to power x e power minus lambda by x factorial. X can be 0, 1, 2 and 3. This is a Poisson's distribution. These are all the topics that are important in the probability. Thank you.